And when you're ready, Kun Stephan, the floor is yours.
Thank you. So thank you for this very interesting talk that we just heard about the ICE driven vehicles. And now I want to give you a brief outlook what we as Bosch can do to electrify those powertrains and how these technologies contribute to a sustainable mobility. So on next slide, also from my side, a short introduction. I'm today responsible for the products that we have in the business field for electrification and the market segment that we called electric vehicles, responsible for strategy and product management, being in the last 6 years also responsible for several strategic and innovative topics like, for example, automated driving, and being within Bosch for more than 12 years now. So next slide, please. So as we all know, air quality and playing an increasingly important role in all our lives. And we just heard this at the very beginning and also now in the last talk. And also we know that several industries cause those kind of pollutions and CO2 emissions. And for us as Bosch, and especially in the powertrain division, we take a closer look in mobility to understand what we can contribute to a sustainable mobility. And you see this in the Bosch motto already, that's called Invented for Life, that we comprehensively address issues to improve the air quality, and also in our own ambitions to be a CO2 neutral company, which we have been in 2020 for the scope 1 and scope 2. But looking at the powertrains, as just mentioned, and as we've seen with modern combustion engine, a lot of things are possible to improve air quality. And in addition, we could use alternative fuels. We could use electrified vehicles like mild hybrids. They basically are driven by an ICE engine, but are supported electrically, ramping up to plug-in hybrids, for example, that are even chargeable outside and drive fewer distances fully electric, or the pure battery electric vehicles that solely have electric machines on board to drive, and fuel cell electric vehicles for certain use cases. So you see a lot of topologies that may help us to become a CO2 neutral mobility landscape. On next slide, just as a short intro where we are as Bosch and as Powertrain Solutions, we are aiming to collaborate in shaping a new era of mobility for all these sustainable mobility aspects in passenger car and also in freight transports. And for this purpose, we do not only offer hardware, what we have just seen in previous talks, but also software and other solutions, also system competence to be in good sparrings to our OEMs. And we are organized within PS in 3 segments. And I think just that you see that electrification is coming closely to all market segments. This is the first line. So we split to pure EV customers, to PES car and light commercial vehicle customers, and to commercial vehicles, off-road vehicles that may all get electrified. This is when we talk about market segments. And of course, the business field, the electrification itself, considering all the products that we have in our portfolio, using business units. So these are our entrepreneurial powerhouses, business units that are taking care of profit and loss of each product, which we have for e-machines, for power electronics, and for batteries. Next slide, please. So our global footprint you can see here on this slide, and we of course aim to be there where our customers are, very close to customers located. Our headquarters are in Stuttgart area, but around Europe we see production facilities, also in the ASEAN region as listed here, production out of China as of today, development and application centers in other Aryan parts of ASEAN, and of course North America. And we already have 2,300 people employed on those 3, start making the first billion revenue within this year. And when chances come up and markets develop, of course, we are flexible in moving closer to those customers. As you may imagine, an e-axle, for example, so a full electric drive, including a power electronics and a gearbox, is weighing around 100 kilograms. So it's better to produce it locally, having shorter distances, also on a sustainability issue, than having a shipment around the globe. So next slide, please. And this ambition that we have is not only to be playing that game, we also have the clear goal to be a technology provider for hardware, for software systems, everything that's related to electrified mobility. And we already have achieved a lot. So we have to mention here that already 90 series projects in the world are fitted with our components. That sums up to 2.5 million cars, pure BEVs, but also hybrid cars that are, let's say, e-powered by Bosch. And each and every year we heavily invest into this technology. I'll later show you also the reason why we do so. Just in this year, another 700 million euros invest in all our products in the portfolio, in our global footprint, to ensure to claim this #1 position that we are aiming for. On the next slide, I just wanted to show you a little bit on a kind of technology stack, the degree of electrification in a vehicle and the components that we have in our portfolio on the one axis. And then the other axis, you would see the CO2 reduction potential of the powertrain topology. And coming from the bottom left, not saying that this has a slow impact on CO2 reduction, because we've seen it before, that technology as of today can really have a huge impact. But going stepwise into electrification, you can add on 48-volt batteries, for example, to have some electrified moments, for example, in parking situations of your car. You can increase that power, then you see on the right axle, up to, for example, the plug-in hybrids. These are the ones that you can then separately charge on charging poles and drive a few kilometers electric, between 20 and 50 kilometers, depending on model and vehicle that you're choosing. Up to the pure battery electric vehicles, you see e-axle. So an e-axle is a combination of the electric motor. You can see in the middle of the slide, and next to it, the inverter. So the power electronic device that is, let's say, guiding the power from the high voltage battery to motor, to getting the momentum on your wheels. And this is all integrated in one product as an e-axle. And to the right, also mentioned the fuel cell stack that's mainly used for commercial vehicles or for bigger, high-class vehicles for longer distances, reducing, though, the battery weight of your vehicle and having an alternative power source, so to say, on board. On next slide, let's have a short look on why this market we believe is coming and what are trends and impacting elements on this market. So let's start on the left end, and of course I think it's important to come from market and customer side. So we see, as of today, China is one of the bigger markets in the world, leading the EV market, so to say, but Europe is growing fast, and we see a lot of regions coming next. And reason there is that, for example, the high voltage battery costs, so which make at least, let's say, 25% of a total vehicle cost as of today, so are very important, very pricey parts of a vehicle. We see a huge cost decrease, 10 to 20% a year, reaching, let's say, kind of a magic number of $100 per kilowatt hours in 2024, which would be let's say the tipping point to make it really affordable. What we do see also are increasing charge points, which is of course needed for those who cannot charge their vehicle at home, that you have the possibility to charge when you're on the road. Legislation side, and we've seen it before for the Euro 5, Euro 6 discussion, for example, and of course in Europe this goes further for Euro 7 that is discussed today, but all the other regions have the same legislational aspects. And in that case, emissions are restricted. And with these restrictions, new powertrain models have to be implemented besides modernization of the classical ICEs. And this brings, with subsidies, for example, in Germany, you would see another 9,000 euros subsidy for an EV, would really bring a push to market. And for end consumer, this is why then the acceptance of EV is increasing. Once it's affordable and once you can have your standard driving behavior for your use cases, it absolutely makes sense also to switch to your until then unknown technology. And environmental awareness is increasing. I think also one of the reasons why we're here together today, also pushing for different modes of transportation. OEMs have understood this trend, of course. They focus on electromobility. If you're following the global news, you see recent announcements of different OEMs in the globe. Basically every week another announcement saying that they set themselves a certain year, a certain target when they want to transform the offering to pure electric vehicles. And also today around 100 models are available. So it's not that there's only one Tesla and you need to buy a very expensive car. You would also find it now in various segments and in various OEMs. Efficiency, of course, is key. So this is also related to the battery that is used in the electric vehicle. So if you could limit the size of your battery in using a very efficient drivetrain, then you save cost on the one side. Or on the other side, if you keep battery size the same, you can extend your E-range, which is also then a good sign for end consumers that have maybe other driving behavior and larger routes to take on a daily commute. On the competition side, as you may believe, we are not the only ones acting in this market. There's a fierce competition. A lot of tier ones like Bosch is claiming to be part of this market, but also new entrants are coming up from other industries claiming a role in electrification. So what do we do now with the trends? This is what you see on the next slide. For us, it's important to mix of powertrains. And this is why we create scenarios every year to better understand the mix of those topologies that I just named in the previous slides. You can see here in different colors, coming from the fuel cell vehicles, for example, in this turquoise color, to the ICE in the blue part. And we do these scenarios based on market trends and drivers, but also on technology, legislation, and everything that's available, and calculate our assumptions, what we may expect in 2030. And as of today, we would say totally 28 to 36% of the global vehicles that are newly sold in that year 2030 will be pure BEV vehicles. Or you can also say around 50% are electrified, another 50 or even 70% if you calculate the 48 volts or the mild hybrids into the game. And around 30% remain on an ICE, whether it's diesel or gasoline engine. In 2035, so another 5 years later, we also see another increase by at least 10 to 20 percentage points, meaning that the time for a technology change seems to be now. On the next slide, I tried to find a deep dive to the ASEAN region, which is, can you move forward, please, for next slide? Yeah, perfect, thank you. So you could see here the ASEAN region. This is, of course, now a bit more granular for all the markets that are there, and it's mainly driven the development of those shares by Thailand, Indonesia, Malaysia, and Vietnam. And as you all know better, but I think than I do maybe, it's a very diverse region and different possibilities for electrification come up depending on buying power, depending on infrastructure, mobility use cases, model availability, and so on and so forth. But for mega cities, of course, the same is true as mentioned before on those trends. Thailand being the most progressive country of those that I've named is now reflected here in those shares. So we still see a 20% electrification share in 2030, which is quite something if you see the numbers that we have in 2025 projected. Next slide, please. And having now in mind those powertrain topologies that's come up and what we see, it's important to understand what portfolio we have to cover this upcoming market. And since every OEM is behaving differently, and we have different markets in different regions, we try to have a very modular that gives us the chance to have on the left side standardized modules. In this picture, you would see a SiC chip, so a specific component that is used in the power electronics on the one side. And to the right side, you will see a fully and highly integrated solution like a rolling chassis, kind of a full electric drivetrain that we jointly developed with Benteler, that you could simply use the upper body of a vehicle and then be already able for driving. And in between, of course, there are a lot of components. As mentioned before, components like the inverter that is guiding the energy from the high voltage battery to the machine, the electric machine that's actually driving the car, 48 volt batteries. So Bosch is not into high voltage batteries, but the 48 volt batteries for the mild hybridization, giving enough power for certain boardnet activities in the vehicle, or a little bit higher integration, but not to the full integration scale. You will, for example, see that e-axle, that's a 3-in-1 combination of the e-machine, the inverter, and the gearbox. or the charger converter, so a combined unit of an onboard charging device and also a converter giving power to the board net of a vehicle. And in between, we have a full flexible delivery scope, so we can really shift one day to another from very small components to integrated system. We have the competence on system side to fully engineer and design those systems. And with this modular approach, we also have the economies of scales that are needed in a market like this to easily ramp up and to be, of course, cost optimized. Our next slide, please. So, but as you may assume, there still are barriers in that market that come up and may limit the growth, or at least where we have to take a closer look that enough investments and innovations are done to promote those activities. For example, on infrastructure side, I think a further extension of charging infrastructure is basically needed, also to enable the mid and long distance travel. To have charge points every time available if you go for public places, if you go for shopping, if you are on motorways, and so on. And we do see a lot of national states programs that do create frameworks and ground conditions, creating subsidies and now building up those infrastructure. This is a huge lever to get people motivated to try it out. At the very beginning, there's a bit of a fear that an electric range of, let's say, 250 to 300 kilometers is not compliant for the daily use. But when you dig deeper, and we did a lot of analysis and end consumer studies on this side, you would see that just 25% of people in Europe, and of course, mobility demand is different in your region, but 25% of the people in Europe, they are happy with charging only once a month. And another 50% are happy with charging only once a week, if you have an electric range of 250 kilometers, leaving another 20%, so to say, that need a daily charging because they have high distance traveling. But you can also say 75% are happy to just charge once in a week already with 250 kilometers electric range. And if that's the case, and we increase the electric range of the vehicles, or we have more charge points available, it's getting even more convenient to switch to battery electric vehicles. Vehicle cost is another thing that needs to be mentioned. So I said at the very beginning that in today's market, for Germany, for example, you would see the 9,000 euros of subsidies for a pure BEV, and I think it's around about 5,000 euros for a plug-in hybrid. And for now, that's fine, and it's also pushing, of course, that market, but you need to have an attractive product cost, so vehicle cost also without those subsidies. And we see this tipping point coming in the middle class segment already in 23, 24. When technology is progressing, when so many EVs are produced in the world that the high voltage batteries, so one of the main levers of cost, can be reduced significantly. I mentioned the significant 100 kilowatt hours per dollar in 2023. This is the tipping point we see, and we see already now a Volkswagen, for example, being very competitive in the pricing they can make. And I just touched it a little bit on the infrastructure side, so the electric range, to make sure that your driving needs are really filled and you feel secure using your car. And all those those hurdles we see that need to be addressed, we do find innovative products in our portfolio. So let's have a look on the next slide, what exactly I mean with this. So on cost innovation, for example, I brought just examples to a matter of time, but on cost innovations, for example, here the power electronics, since the first generation that we brought into the market around about 5 years ago, and around about the next generation in 3 years, so between 8 years, we do find the power density that is now increased by around 700%, reducing the cost by a factor of 10. Yeah, so seeing that the technology progress, bringing us more power density, more density is on the end efficiency, and on the other side, being more cost competitive and having pricier products helps the technology to come into market. On system integration, if you assume that you have 3 certain parts like the inverter, the electric machine, and the gearbox that you need to mount into a vehicle, you may have a lack of space depending on your vehicle design or how the way, if you have a front-wheel drive, all-wheel drive, how you structure your vehicle. Building a full integrated system gives us the opportunity to really have the best, let's say, an optimized fit of product size and technical parameters. And in combining those three products, we reduce weight and cost, of course, and we increase efficiency. We save the housing of three components and integrate it in one. And with this e-axle, we can achieve a drivetrain of 96% efficiency, right? So just 4% energy loss coming from high voltage battery to the drive. 48 volt battery is something to mention. This is a very commodity and standardized product, but still needs to have a high flexibility. As said before, if you have regenerative braking, for example, the energy needs to be stored for a short amount of time in the system and then supplying other smaller drives or using the board net of the vehicle. And having this for an attractive cost makes it easier for the OEMs to step firstly in the mild hybrid electrification. And last but not least, on the right side, a new technology with 6 semiconductors coming up for the power electronics, giving another boost on efficiency side. You can either choose then between 6 percentage points more electrical range or 50 percentage point less energy loss, which then increases your power density, which then increases the efficiency of the drivetrain. So it's depending on the size of the semiconductor we build into this power electronics, that we do this based on requests from our customers. We can give the technology another push. Okay, having a look at the last slide and the summary of today's short intro into electrification, and I hope at least I made you a bit curious on what all we have in our portfolio and how the technology is helping us for achieving clean air. So what's important to understand, although, is that all modern powertrain topologies contribute. And we do see e-mobility coming as the mass market, let's say 2035 and later. We clearly see the pure BEV as the dominant technology in the world. The electrification portfolio that we are offering is not only for pass cars, but also for commercial vehicles, for off-road, and all the vehicles that you may have in mind. And we do cover all integration level, from subcomponents to higher integrated systems, depending on OEM needs and regional aspects. And with our global footprint as Bosch, we can use the global network that we have, and we will certainly achieve our ambition to be the #1 in electrification. So thank you for your time. I would hand back, and I'm happy to see some questions for the discussion round.
Thank you so much, Stephan. And that is the wrap for today's session presentation.